Imagine looking up at the night sky and seeing a bright, fast-moving object. This isn't a shooting star, it's Apophis, an asteroid that could change life on Earth forever. Are we ready for the impact? Apophis, named after the ancient Egyptian god of chaos, was discovered in 2004. Its size, speed, and trajectory make it one of the most talked about near-Earth objects. Early predictions even suggested a possible collision with Earth in 2029 and 2036, sparking widespread concern. Now, scientists are closely monitoring Apophis, calculating its every move. What would happen if this colossal rock actually hit our planet? The destruction would be unimaginable, with cities obliterated and global chaos ensuing. This video will delve into the terrifying possibilities and explore whether we have any hope of stopping such a catastrophic event. Buckle up, because this is a story of the future we hope never comes to pass. Discovery and naming of Apophis. Imagine stumbling upon something so extraordinary, so potentially catastrophic, that it shakes the entire scientific community. That's precisely what happened on June 19, 2004, when astronomers Roy A. Tucker, David J. Tholen, and Fabrizio Bernardi peered through their telescopes at the Kitt Peak National Observatory in Tucson, Arizona. They discovered an asteroid that would come to be known as Apophis, a name that would soon evoke a mix of fascination and fear worldwide. Initially, the discovery was almost a stroke of luck. Technical and weather-related issues allowed the team only a brief 2-day window to observe this cosmic rock. But fortune favored the vigilant. Later that same year, astronomers at the Siding Spring Observatory in Australia managed to spot the asteroid again, ensuring it stayed in our sights. At first, this celestial body was simply called 2004 MN4. It wasn't the most exciting name, but it served its purpose. As astronomers continued their observations, they noted something particularly alarming. This asteroid was making a beeline for Earth. On December 21, 2004, Apophis passed within 8.96 million miles of us, a close shave in astronomical terms. By December 27, 2004, scientists had dug up some pre-discovery images from March 15, 2004. This older data helped refine Apophis's orbit, thanks to the magic of radar astrometry in January 2005. This fine-tuning revealed just how close Apophis would come to Earth. Fast forward to June 24, 2005, when 2004 MN4 graduated from its provisional designation to earn a permanent number, 99942. This official numbering meant one thing: the asteroid was ready for a name, and what a name it got. On July 19, 2005, it was christened Apophis, after the Greek name for Apep, the ancient Egyptian god of chaos and darkness. Apep wasn't just any deity. He was the eternal enemy of Ra, the sun god. Picture a colossal serpent lurking in the shadows, always ready to pounce and swallow the sun. That's Apep, a symbol of chaos held at bay by the god set. This dark myth seemed a fitting namesake for an asteroid that could bring such upheaval. Interestingly, the choice of name had a touch of pop culture. Tholen and Tucker, two of the asteroid's discoverers, were fans of the TV show Stargate SG-1. In the series, Apophis was a menacing alien bent on Earth's destruction, a role strikingly similar to the mythological Apep. This villain's backstory of posing as a god in ancient times likely inspired the asteroid's name. Talk about life imitating art. But there's more. The pronunciation of Apophis has its nuances. In Greek mythology, it's pronounced with the accent on the first syllable, Epi-Ephis. However, thanks to Stargate SG-1, the asteroid's name is usually accented on the second syllable, Cha-Zi-Apaphe-Zi-Rai. Apophis isn't just any asteroid, it's one that has the scientific community and the public alike buzzing with both fear and fascination. So, what makes this space rock so special, and why should we care? Size and composition. Let's start with the basics. Apophis is about 340 meters, 1,100 feet in diameter, roughly the size of the Empire State Building. That might sound small compared to Earth, but when you consider its mass and speed, it's a pretty big deal. Imagine something that massive hurtling through space. The energy it could release upon impact is mind-boggling. We're talking about an explosion equivalent to hundreds of megatons of TNT. Just picture the devastation. It's like a nuclear bomb going off, only worse. Now, what's Apophis made of? It's an S-type, silicaceous asteroid, which means it's composed mainly of silicate minerals and nickel iron. These materials are highly reflective, making Apophis appear bright when viewed from Earth. Its shiny surface suggests it formed in the inner regions of the asteroid belt, where such minerals are abundant. Orbital characteristics. Apophis follows an elliptical orbit around the Sun, taking about 323 days to complete one loop. What's concerning is that its path intersects with Earth's orbit, which is why it's on our radar. When scientists discovered Apophis in 2004, their calculations predicted a high chance of it hitting Earth in 2029. That prediction caused quite a stir, to say the least. Although later observations have downgraded the risk for 2029, the fact remains: Apophis is coming uncomfortably close. It quickly gained notoriety as an asteroid that could pose a serious threat to Earth. The buzz started when astronomers predicted that it would come uncomfortably close in 2029. The very idea sent shivers down spines worldwide. But let's break it down. Thanks to diligent observations and calculations, the risk of an impact in 2029 was later ruled out. Imagine a collective sigh of relief from scientists and the public alike. The potential threat posed by another close approach in 2036 was also dismissed. However, until March 2021, a small chance of an impact in 2068 still lingered like a shadow over our future. Then came March 5, 2021. Apophis made a distant flyby of Earth, a perfect opportunity for astronomers to get a closer look. Using powerful radar observations, they refined the estimate of its orbit around the Sun with extreme precision. This wasn't just a minor adjustment, it was a game changer. They were able to confidently rule out any impact risk in 2068 and long after. Imagine the relief that must have swept through the scientific community. Davide Farnocchia of NASA's Center for Near-Earth Object Studies, CNEOS, put it into perspective. A 2068 impact is not in the realm of possibility anymore, and our calculations don't show any impact risk for at least the next 100 years. With the support of recent optical observations and additional radar data, the uncertainty in Apophis's orbit shrank dramatically. It went from hundreds of kilometers to just a handful when projected to 2029. This improved knowledge of its position provided more certainty of its future motion, allowing scientists to remove Apophis from the risk list. Now, let's talk about that risk list. Farnocchia was referring to the Sentry Impact Risk Table, maintained by CNEOS. This table keeps tabs on the few asteroids whose orbits take them so close to Earth that an impact can't be ruled out. With the recent findings, Apophis no longer appears on this list. This is thanks to the combined efforts of optical telescopes and ground-based radar, which help characterize every known near-Earth object's orbit to improve long-term hazard assessments. To arrive at the Apophis calculations in 2021, astronomers used the 70-meter, 230-foot radio antenna at the Deep Space Network's Goldstone Deep Space Communications Complex near Barstow, California. They tracked Apophis's motion with incredible precision. Despite being nearly 10.6 million miles, 17 million kilometers, away, they acquired data about its distance with an accuracy of about 150 meters, 490 feet. JPL scientist Marina Brozovic, who led the radar campaign, shared the excitement. This campaign not only helped us rule out any impact risk, it set us up for a wonderful science opportunity. In an innovative twist, Goldstone collaborated with the 100-meter, 330-foot Green Bank Telescope in West Virginia. This bistatic experiment, where Goldstone transmitted while Green Bank received, doubled the strength of the received signal. This collaboration enabled imaging of Apophis with unprecedented detail. But the work doesn't stop there. The radar team continues to analyze its data, and they expect to learn more about the asteroid's shape. Previous radar observations have suggested that Apophis has a bilobed, or peanut-like, appearance. This shape is relatively common among near-Earth asteroids larger than 660 feet, 200 meters, in diameter. About 1 in 6 have 2 lobes. Astronomers are also working to develop a better understanding of the asteroid's rotation rate and its spin state, the axis it spins around. This knowledge will be crucial when Apophis encounters Earth's gravitational field in 2029. This close encounter could change its spin state and even cause asteroid quakes, a phenomenon where the asteroid's surface experiences shaking or quaking due to gravitational interactions. The Yarkovsky effect. One of the key factors influencing Apophis's trajectory is the Yarkovsky effect. This phenomenon occurs when an asteroid absorbs sunlight and then re-emits it as heat. This thermal radiation can create a small but significant force that alters the asteroid's orbit over time. For an asteroid like Apophis, even a slight change in trajectory due to the Yarkovsky effect can have major implications for its future path. Scientists are studying Apophis extensively to understand how the Yarkovsky effect might influence its orbit. This includes measuring its thermal properties, rotation rate, and other characteristics that could affect how it absorbs and emits heat. By understanding these factors, researchers can make more accurate predictions about Apophis's future movements. What if? With that being said, let's take a moment to imagine the unthinkable. Apophis hitting Earth. It's a chilling thought, isn't it? Despite the reassurances from scientists, it's worth exploring what might happen in the unlikely event that Apophis were to collide with our planet. First, let's talk size. Apophis measures about 1,100 feet, 340 meters, in diameter. To give you some context, that's roughly the height of the Eiffel Tower. Now, imagine an object of that size hurtling toward Earth at a speed of about 30 kilometers per second, 67,000 miles per hour. The energy released by such an impact would be immense, comparable to thousands of nuclear bombs detonating simultaneously. The immediate effect of an Apophis impact would depend largely on where it strikes. If it were to hit a populated area, the devastation would be catastrophic. Buildings would be flattened, infrastructure obliterated, and the loss of life would be immense. Even in less populated areas, the impact would create a massive crater, sending shockwaves rippling across the landscape. But it's not just the direct impact we need to worry about. An asteroid strike of this magnitude would eject huge amounts of debris into the atmosphere. This debris could darken the skies, blocking sunlight and causing a dramatic drop in temperatures, a phenomenon known as an impact winter. Crops would fail, leading to food shortages and widespread famine. The environmental effects would be felt globally, affecting weather patterns and ecosystems far from the impact site. One of the most famous impact events in Earth's history is the Chicxulub impact, which is believed to have caused the extinction of the dinosaurs about 66 million years ago. The asteroid responsible was much larger than Apophis, but it provides a grim example of the potential consequences. The Chicxulub impact caused massive fires, tsunamis, and a global cooling effect that wiped out about 75% of all species on Earth. In the case of Apophis, the damage might not be on the same scale, but it would still be profound. The exact effects would depend on several factors, including the angle of impact, the composition of the asteroid, and the nature of the terrain it strikes. For instance, an impact in the ocean could generate massive tsunamis, inundating coastal regions and causing widespread destruction. So, what would humanity do in such a scenario? Fortunately, we have some time to prepare. With current technology, there are several potential strategies to deflect an incoming asteroid. One idea is to use a kinetic impactor, a spacecraft designed to collide with the asteroid and change its trajectory. Another option is the gravity tractor method, where a spacecraft flies alongside the asteroid and uses its gravitational pull to slowly alter the asteroid's path. NASA and other space agencies are already working on missions to test these concepts. For example, the Double Asteroid Redirection Test, DART, mission aims to demonstrate the kinetic impactor technique by deliberately crashing into a small asteroid to see how its orbit changes. These efforts are crucial for developing effective planetary defense strategies. Public awareness and international cooperation are also essential. A potential asteroid impact is a global threat, and addressing it requires collaboration between countries and organizations worldwide. By pooling resources and expertise, we can better monitor near-Earth objects and develop strategies to mitigate the risks. While the chances of Apophis hitting Earth are extremely low, the impact scenario serves as a reminder of the importance of continued vigilance and preparedness. Advances in technology and science have greatly improved our ability to detect and track potentially hazardous asteroids. With ongoing efforts, we can further enhance our planetary defense capabilities and ensure that we're ready to face any future threats from space. Monitoring and mitigation efforts. Given the potential threat posed by Apophis, space agencies around the world are investing in monitoring and mitigation efforts. NASA, ESA, and other organizations have dedicated resources to tracking near-Earth objects, NEOs, like Apophis. Advanced telescopes, radar systems, and space missions are all part of the effort to keep tabs on this and other potentially hazardous asteroids. One of the most promising areas of research is asteroid deflection. Scientists are exploring various methods to change the trajectory of a threatening asteroid. These methods include kinetic impactors, spacecraft that collide with the asteroid to change its course, gravity tractors, spacecraft that use their gravitational pull to alter the asteroid's path, and even nuclear devices. Each method has its challenges and potential risks, but the goal is to develop a reliable means of preventing a catastrophic impact. What to expect? Let's break down what we can expect during these upcoming close approaches, particularly in 2036, and what future projections hold. The 2029 close approach. Mark your calendars for April 13th, 2029. That's the day when Apophis will pass less than 20,000 miles, 32,000 kilometers, from Earth's surface. To put it into perspective, this is closer than some of our geosynchronous satellites. During this close approach, Apophis will be visible to observers on the ground in the Eastern Hemisphere without the aid of a telescope or binoculars. Imagine looking up and seeing a bright dot moving rapidly across the sky, both an awe-inspiring and humbling sight. For astronomers, this is an unprecedented opportunity. The 2029 close approach will allow them to get a close-up view of a solar system relic that has now become more of a scientific curiosity, rather than an immediate hazard to our planet. It's a chance to study an asteroid up close and learn more about these mysterious visitors from the cosmos. As Apophis approaches, Earth-based telescopes will closely observe it, capturing data that will be invaluable for understanding its properties and behavior. This close encounter with Earth's gravity might even give scientists new insights into how such interactions affect an asteroid's orbit and physical characteristics. And then there's 2036. Although the likelihood of an impact on this date has been significantly reduced, it's not entirely off the table. Researchers are constantly updating their models and observations to get the most accurate predictions. It's like a cosmic game of chicken, and we're all holding our breath. The 2036 approaches. In 2036, Apophis will make two significant passes near Earth, one in March and the other in December. These events are notable because they bring Apophis closer to our planet than it has been in recent times, though it still won't be dangerously close. March 27, 2036. On this date, Apophis will pass at a distance of about 0.3089 AU, 46.21 million kilometers, 28.71 million miles from Earth. This distance is roughly 28 times the distance between Earth and the Moon. To give some perspective, Venus will be closer to Earth at around 0.2883 AU, 43.13 million kilometers, 26.80 million miles. On May 30th, 2036. Although Apophis will come within a third of the Sun's distance from Earth, it is not expected to pose any threat. December 31st, 2036. Later in the year, Apophis will pass a bit further away, at approximately 0.33 AU, 49 million kilometers, 31 million miles. This distance is still considerable and poses no risk of impact, allowing astronomers to continue their observations and refine their predictions. These approaches in 2036 provide an excellent opportunity for scientists to study Apophis's trajectory and refine their models of its orbit. This data helps ensure that future calculations are accurate and provides a clearer picture of potential risks, even if those risks remain minimal. The 2051 approach. Looking further ahead, Apophis will make another close approach around April 19th or 20 in 2051. During this encounter, it will come within about 0.04 AU, 6.0 million kilometers, 3.7 million miles. This will be the closest encounter since the 2029 flyby, bringing Apophis within 10 million kilometers of our planet. Despite the proximity, this distance is still well within a safe range. However, this close approach will be a significant event for astronomers, as it offers a chance to study the asteroid in greater detail. Observations during this period will help scientists understand any potential changes in Apophis' orbit and provide insights into its composition and structure. 2066 and 2068. As we move into the 2060s, Apophis will approach Earth in September 2066. After this, it will be further from Earth than the Sun from February 2067 to December 2071. This period represents a relatively quiet time for Apophis in terms of close approaches. April 12, 2068. On this date, Apophis will be about 1.864 AU, 278.85 million kilometers from Earth. This distance is significantly greater than the Sun's distance, making any impact scenarios highly improbable. The asteroid will be safely far from our planet, continuing its orbit around the Sun without posing any threat. The 2116 projection. The long-term outlook for Apophis includes a potential close approach in April 2116. Projections suggest that Apophis could pass as close as 0.02 AU, 3 million kilometers, or as far as 0.1 AU, 15 million kilometers from Earth. This range of potential distances highlights the uncertainty in long-term orbital predictions. Ramses. The European Space Agency is ramping up an exciting new mission called Ramses, short for Rapid Apophis Mission for Space Safety. This mission is set to make a splash as it will fly to the near-Earth asteroid 9942 Apophis and tag along as it zooms by Earth in 2029. The asteroid's close encounter will be an unprecedented opportunity to study an object up close that won't be this near again for thousands of years. Scheduled to launch in April 2028, Ramses aims to reach Apophis by February 2029, just as it makes its closest approach to Earth. This asteroid will come within a mere 19.794 miles, 31.860 kilometers, of our planet, closer than the distance where geosynchronous satellites orbit. That's an extraordinary chance for scientists because large asteroids like Apophis don't swing by Earth this closely very often. If Ramses succeeds, it'll provide crucial data and insights that we can't get from a distance. The Ramses mission is not just about observing from afar. By arriving before Apophis's close flyby and sticking with it through and after the encounter, Ramses will provide critical data on how Earth's gravity affects the asteroid. Scientists will observe how Apophis's surface might shift or react to the tidal forces exerted by our planet, revealing hidden details about its internal structure, density, and composition. This kind of detailed study is essential for understanding not just Apophis, but also for developing potential strategies to deflect asteroids if one ever threatens Earth in the future. It will perform a detailed flyby from about 2,500 miles, 4,000 kilometers away, and then return in June to enter orbit around Apophis for an 18-month mission. The combined data from Ramses and Osiris Apex will offer a comprehensive view of the asteroid, helping scientists piece together a more complete picture. This mission also complements ongoing efforts to study other near-Earth objects. For example, the European Space Agency plans to launch its Hera spacecraft in October 2024. Hera will follow up on NASA's DART mission, which successfully impacted the double asteroid Didymos and Dimorphos. Hera will survey the aftermath of that collision to understand better how impactors can alter an asteroid's trajectory, a crucial capability if ever we need to defend Earth from a potential impact. Ramses and Osiris Apex are stepping up to get a close look at this asteroid, and it's going to be a thrilling ride for space nerds and casual stargazers alike. These missions are our chance to see what Apophis is really made of, and to figure out how we deal with a bigger asteroid in the future. It's like a cosmic test drive for planetary defense, and we're all in the front seat. If you're as excited as I am about what's coming up, hit that like button, subscribe, and ring the bell so you don't miss any updates. Thanks for hanging out with me today. Until next time, keep looking up and stay curious about the universe.